Right, so we did talk about this the other day about magnitude vectors, and I think some of the questions that you were doing the other day looked at this, but let's just complete the notes on it. So remember, magnitude is shown by the two lines either side, and it's always going to be Pythagoras theorem, and we will alwabe finding the hypotenuse, so we're always going to be squaring and adding them. Okay, you don't have to worry, is it exact? We know that because we're squaring these numbers, secretly it doesn't actually matter if any of the values are negative, because when we square them it becomes positive anyway. It's just something that you need to be careful with when you're, if it's on the calculator, because you're seeing it in the calculator, that you're making sure you can bracket around those negative numbers. So if I were to find the magnitude of A, it would literally be the square root of 2 squared plus 3 squared. If this was on the non-calc paper, you would be leaving it in third form. So this would be, 4 plus 9, so that would be root 13. So you could leave it as root 13. To be honest, I would probably leave it in third form for most things. Okay? Magnitude of B, now you may look at this going, well, hang on a minute, it's got 3 letters. It's just a similar principle in that this would be the square root of 3 squared plus negative 2 squared plus 4 squared. Okay, so you're just squaring and adding all of them together. Pardon? Yeah, that's negative there. But remember what I say, when you're putting it in, if you're using a calculator, put brackets around the negative part, not the square. Don't include the square in there because it's going to negate the bracket. So this would be 9 plus 4 plus 16, which is root 29. Okay? And again, you can see it in so. Anything else? Yeah? Okay, parallel vectors, so we talked about these as well, but let's just do questions just so we can get some. So if vectors are going to be parallel to each other, then they can be factorized somehow. In other words, they can be written with a value in front of them. So if you're able to do that, then that shows that they are parallel. So 2i minus 3j minus k is parallel to 4i minus 6j minus 2k, because you can write this as 2 lots of this. Okay? Should be answered. Another example. They've said find R and S given that A is parallel to B. So we know that these two are parallel to each other. So A is equal to something multiplied by B. Okay? So we know that vector A is equal to something multiplied by B. Obviously, you can write the other way around if you look at that. So 2 negative 1R is equal to something multiplied by S to negative 0. So I've just used this lambda symbol and starts popping up in vectors. Don't panic, it's just like an X or a Y. So, or a beta, we use the same for angry. So because we would make this statement, we need to somehow find the value of lambda. How can we do that? So here I've got a 2, and then here I've got an S, so they can't be compared because I don't know what S is. Here I've got negative 1 and a 2, and here I've got an R, I don't know what that is, and negative 3. So which is the thing that's going to help you? Yeah, so this bit here, you will have that kind of. So here I can say that negative 1 is equal to 2 lambda. Because remember, if there is something in front of this, then everything is multiplied by it. Yeah. And obviously we can rearrange this to show that lambda is negative 1/2. Anything else? So then we can say that 2 negative 1R is equal to negative 1/2 S to negative 3. And now we can set ourselves some equations to find S and R. So Jennifer, what would I write for to find S, what statement can I write? In a similar way that we did here. So we're trying to find the value of S. So let's see where the S is now. Not quite. Okay, so the S is the top number, yes? Yes. Do you see how Olivia said that? So 2 is equal to negative a half multiplied by S. Because this negative a half affects everything here. Yes? And so that means that we're always comparing our top numbers, or our middle numbers, or our bottom numbers. Yeah? And so we can make that statement. The reason we chose this middle one here initially is because we had both of these two values which enabled us to find that. Okay? You all right with that? So obviously if we're making this, S would be, you've got choices 2 divided by negative a half, or 2 multiplied by 2 over negative 1, so S is going to be what? Huh? Pardon? See, really it's negative. Okay, remember if you're dividing by a fraction, you're going to multiply it by its reciprocal. Okay, the sign stays there, so this is equal to 2 over 1, so it's 2 times 2, which is 4, 1 times negative 1, which is negative 1, which gives us negative 4.
That's
That's a scribble out. So change my thing. Okay, so shelves, what should I write to find R?
R equals negative
Yes. Okay, and this one's more straightforward. This is equal to negative 3 over 1. Yes. So we've got top times top, bottom times bottom. Well, first you've got negative multiplied by negative, so my answer is going to be positive. So we've got 1 multiplied by 3, 2 multiplied by 1, so it's 3 over 2. If you want to put 1.5, okay? Because we've got a negative multiplied by negative. Okay. So that's knowing that things are parallel. So as you can see, it doesn't have to be a whole number. So like whilst we were able to bring a factor of 2 out here, that's nice and obvious, sometimes our factor can be a fraction, it can be negative. It doesn't have to be a whole number. So just be aware of that. Okay. Unit vectors. Okay, now what's different about this thing compared to the other things that we've seen? How is it written? With a little hat on it, yes? So if you see anything with a little hat on it, I was going to make some really dodgy joke. No. So if you see anything with a little hat on it, it means we're talking it's a unit vector. Okay, now a unit vector always has to have length 1. Now, we said a minute ago that this vector here has a length root 13. So what happens is that if you want to say, okay, how can I rewrite that vector as having just length 1? Well, if we knew that this had length 5, we would just divide it by 5. Yes, that would be pretty obvious if we wanted to have it. So, I should choose a different color stuff. I don't want to correct that's that. Okay, we're still talking about this one here. So we knew that the length was root 13. maybe, no, I'm going to do it in a different one. So I'm going to talk about a 3, 4, 5. Okay? So if this vector was 3i plus 4j, we would find that it had length 5. Yes? So if I wanted to show that it was length 1, then it would be 1/5 of that original vector. Does that make sense? So if this has length 5 currently, and I want it to only have length 1, then I'm going to have 1/5 of that. Because that will then have a length of 1. Because 1/5 of 5 is 1. Yes? If it had length 16, what fraction would I put in front? 1/16. Yes? Makes sense? Jennifer? Yeah. So, if it had length root 13, whilst it's a weird horrible number, the same principle applies. To have a length of 1, we would just have 1 over root 13 of it. Okay? So that's all you have to do. You have to just find the length of it, and that is going to go as your denominator under 1. Okay? Now, these are both equivalent statements. In fact, these all 3 of them. Because obviously this is our column notation and this is our IJ notation, so we know that they are both the same. But we've also learned about these things, that when we have a third on the bottom, we normally do what's the word called? Rationalize it. We often rationalize it. So if I want to rationalize 1 over root 13, nice, it's root 13 over root 13. So this becomes root 13, and this just becomes 13. Yes? So that's the difference between these two and this one. It's just been rationalized. Okay? So all 3 of these are equivalent statements. It's just that they're in slightly different formats. Okay? So in general here, your unit vector is your original vector divided by the length of it. Okay? Or 1 over a multiplied by a. Okay, both of those two mean the same. Alright, moving on, yeah? Colinear points. Colinear means that they're in a straight line. Okay? And it's, if you can show things are parallel to each other and having a common point, it means they're colinear. To be honest, it doesn't come up loads. I'm not going to harp on about it that much. But if you can show that they're parallel, so if you can do that, bringing out a common factor, and as long as you've got a common point between them, you would show that they were in a straight line. Okay? Now, we talked about position vectors the other day. Do you remember that? Position vector is based from the origin, yes? So if this had the coordinates 3, 2, then this position vector would be 3, 2. Nice and simple, yes? If we're talking that these are their position vectors, then if we wanted to go from P to Q, you will always be going the opposite way of P plus Q. Do you remember that? Because we have to follow those paths. And so essentially, if you've got any letter to any letter, so from P to Q, it would be Q minus P or minus P plus Q. These are obviously both equivalent, yes? But it will always be the opposite direction of the first letter plus the actual direction of the second one. Okay? That's going to come in later. Alright. I can see the enthusiasm. It's just squeezing. I know, sweetheart. Unfortunately, we have this as one of our lessons, so we need to make those things and already.
Period 1. We haven't caught ourselves in so long. I don't know. I don't know if we taught how many bases.
Anyway, let's not check too much that. Right. Scalar product or dot product. Okay? You get given this in this format printed in your formula sheets. What have I done to this? Who knows? Okay, so the dot product or the scalar product. It's derived from the cosine rule. Okay, if you remember this multiply, or no, this squared plus this squared minus this squared over blah, 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 blah. Okay, it's derived from that, don't panic too much about it. But it's all connected between these vectors. Okay, that's an arrow that way, and that's an arrow that way. And this is your angle in between them. Okay, so here's your vector A, here's your vector B, this is the angle in between them. Okay. Now what this says is that the dot product, which I'll show you how to do that in a second, is equal to the length of the A multiplied by the length of B multiplied by the cosine of the angle between them. Why are they multiplied? It's just a rule.
It's a further.
Yes, I was, totes. But no, we're multiplying. Okay, so it's the length of A multiplied by the length of B multiplied by cosine of the angle between them. Okay. Now, this bit here, I'm hoping this doesn't confuse you. What it says here is that the angle, okay, you can see that this vector shot out that way, this vector shot out that way. So that's really the angle in between them. Now, if this vector was shooting this way, and this vector was shooting out like that, then the angle we're talking about is secretly this beta one here. Because if I were to shift this one in the same direction, okay, so it's still projecting in the same direction, then the angle in between them is secretly this, not this angle. Does that make sense?
Yeah.
I know, and the thing is, it's only an obscure question that it will affect you. So I'm not going to labour on it too much. I'm just going to have mentioned it, should it come up, and you go, huh? Then you perhaps look at the notes and go, oh, this is one of those weird ones. Okay? As I say, it doesn't come up very often. Here, if these two vectors are pointing inwards together, then obviously it would be the same angle here, so that's fine. It's still going to be this angle here. If this one was shooting this way, and this one was shooting that way, then again, we'd have to project this one to keep going, and it would be this as your angle in between them. So essentially, they both have to be shooting away from each other, and that's the angle that we're interested in. Okay? So it's only, as I say, they're only obscure questions, but you have to be going away from each other, and that's the angle between them. Okay?
Wait, I still don't get why that first one would be that thing, because would if you measure back to the angle that one would still be shooting this way.
This is shooting this way.
So it's kind of like before that.
Like if you put an arrow there, it's the same direction, but nothing. Like where you just do the line.
It drew the line down.
Yes, you have an alpha pointing the same direction.
So now that we're going to
It's like before you're extending the line and then like the
Before that, the
area.
other angle didn't exist, so we used the line.
Yeah, the line is dotted between them now.
Okay.
Yeah? Good teamwork. So maybe this is the format you're given it. Can't remember. I can't remember. Let's have a look. But we know that it means the same thing, that these two are can be multiplied by that to give the dot product. Yes. Okay. Now, what is this dot product she's talking about? Well, it's pretty straightforward. I think you might even get this as well. If you're finding the dot product, you're just multiplying the corresponding coefficients. So we would multiply P and S, and we would add that to Q multiplied by Q, and we would add that by R multiplied by U. Huh?
PSQUR.
What's that?
They are.
Let's know. Alright, so super easy to do. Yes, you're literally just multiplying numbers and adding them together. We can all do that and get excited. Now, I personally don't like so much when they write in IJK notation. I like to rewrite into column, but it's totally up to you. So I personally would do this. Okay? And then you're just multiplying corresponding numbers, and it just makes it a little bit easier to make sure you're matching them up. So this would be 2 multiplied by 1 plus -3 multiplied by 3 plus 4 multiplied by -2. So I'm just multiplying my corresponding numbers together and adding those up. So that's 2, take away 9, take away 8. Bless you. Yeah, you're right now.
Wait, what is the dot?
It just you're essentially means you're multiplying them. That's what you're doing. And we know that dot, when we see a dot in maths, it does mean multiply as well. Yeah. It's just that you have to multiply corresponding bits and add. So what is 2 take away 9 take away 18?
-8.
Oh, totally take away 8.
Total.
Oh my gosh, it's really stuck. So 2 take away 9 is
-7.
take away another 8.
That's what I said.
-13.
That's so what I said. I just like
Okay, at this point we're remembering that we have to not count back. Yours was -1, I was kind of confused.
Yeah, I was confused.
Okay, so
So tired. I can't do this.
I'm hoping we don't have. We are going to have a morning exam. Okay.
Oh, God.
Luckily, it's going to be the calculator.
Oh, yeah.
Because our mental math, they're not so hot. People, not so hot. Awkward, very awkward.
So that's the examiner. I just erased the 5 by accident. Okay.
So we made an example that was the bottom page. That's the excessive page.
Above and beneath. I don't know
Above
if
and
the
beneath.
I thought it was like an English term, like above and beneath.
Alright, okay, so we're going to find the angle between these sectors. Okay? So these are the rules that we need to know. If we know that the cosine of the angle, we need to find the dot product, and we need to find the length of each vector. Yes, that's all we need to do for both of these. So, number 1. So first of all, I'm going to find my length of both of these. So Cameron, how would I do it for this first one? That's an A, not a 9. I see.
-1 and 3, so that's a column vector.
Oh, you want it as a column? Okay.
Yeah. Yes, please. And then -1 and 2 for the other.
Okay.
No?
I want to find the length bit. Yeah. Tell me how to do it.
-1 squared. Next 3 squared. Plus 3 squared. And the root.
What's -1 squared, tell me? And what's 3 squared? And what's 1 plus 9? So that's root 10, yeah? Okay. And just now, what's length of B?
-1 squared. Yeah, square root of -1 squared plus 2 squared.
What's -1 squared?
1 plus 4 square root of 5.
Lovely. Okay, so that's our first bit of information we need. Now we need to find out the dot product. So Sarah, you can do this for me.
And plus 3.
Okay, so -1 multiplied by -1 is plus root of 2. Okay, so that's the bits, they're the components for that cosine rule, yes? So now we can say that cos theta is equal to the dot product, which was 7, over these two lengths multiplied by each other. And you can just write root 10, root 5. Does anyone know how we can join these together? What happens when I just multiply these? What says? Just becomes, it just becomes root 50, which probably does simplify. But just so you know, that can be written as cos. Oh, cos? What are you still making stupid woman? Cos theta equals 7 over root 50. Okay, so when we've got root 10 multiplied by root 5, you can just multiply those numbers and stick it under the new root. So, if we know that the cosine of the angle is 7 over that, how do we find the angle itself?
Inverse.
Inverse. So this we would need our calcs, unless it was a special triangle. Okay, so this is likely to be on the calc paper, thankfully, because some of the things coming out not too awesome. It's early. So we need to do inverse cos of that bad boy. And is anyone volunteering to do that? Alright, so there's that one, and then the second one is going to be very similar. Go, beep beep. So, so we need to find the length of A. Olivia, how would I do that?
0 squared plus -5 squared plus 4 squared.
Is the answer? So that's obviously 0 plus 25 plus 16. So 25 plus 16 is
30.
nice. So that's 341. Haven't won any, you'll do this one.
Yeah, there you go.
And the length of B, Jennifer?
-5 squared plus, times -5
No, it is plus.
plus 3 over 10 plus 2 squared. 25 plus 1 plus 9.
What did you do the 9 plus 1 with?
35.
Okay, so that's root 41, root 35. And Olivia, what else do I need to find? Oh, I just asked you, I did. Ali, sorry. Sorry. What else do I need to find? So in our formula, cos A equals blah, blah. Yeah, the dot product. So what's it going to do for this bad boy?
For A.
What, A dot B. So what's the actual answer going to be? I don't know the numbers. I can't, so I'm trusting you.
0 times -5 plus -5 times -1 plus 4 times -3.
Okay, so that's what?
0. 35 plus 5 plus -12.
Okay. Yeah. And then we're going to stick those values in. So we say that cos theta is -7 over root 41, root 35. I don't know what 41 is, but 35 is, so I'm just going to leave it like that. And then we chuck that in our calc, so cos -1 of the answer. And it's something to like for a number. I'm going to make some. Alright, okay, so then that one's 63.3.
They're all fair.
Okay, a couple of things. This should be pretty quick. If two vectors are perpendicular, we know that that means that the angle would be 90 degrees, yes? Alright. Now, because our dot product rule involves cosine of cos, and the cos of 90 we know is actually 0. Okay? So since the cos of 90 is 0, it means that if our vectors are perpendicular, it means that the dot product would actually equal 0. Okay? Because obviously if this is 0, then it doesn't matter what these lengths are, if the whole thing's going to be 0. Okay? So a common question is, show that these are perpendicular vectors. So what you would do to that, for that, is that you would find, oh here, so show that blah blah is perpendicular to blah blah. We would find our dot product, so we would have 13, 23, 7, 2, 1, negative 7, and we would find our dot product. So Cameron, how do you find the dot product again? So tell me what's right, please.
13 times 2, 23 times
Plus, yeah.
1 and plus 7 times -7.
And so 13 multiplied by 2 is 23 plus what? Times 1 is
22
and 7 multiplied by negative 7.
and minus
There's only one negative here. So it's negative 49, yeah? And oh look, 26 plus 23 is 49. Take away 49 is 0. So, and then you would say, since the top dot product is 0, they are perpendicular. Okay. Okay. So that is a common type of question. So, as I say, most of the time they talk about perpendicular, they might talk about parallel, but if they are parallel, then we know that the angle between them is either 0 or 180. Okay, so if they are parallel, they're either doing this, going in the same direction, in which case that angle is 0, or they're going in opposite directions, in which case that angle is 180. Yes? If it was 0, then that value is 1, cos of 0 is 1, which means that the dot product would be just equal to those two lengths multiplied by each other. If it was 180, then it would be negative the two lengths multiplied by each other. Okay? So there you go. If A is exactly the same as B, then it's going to end up that A squared is going to be your dot product. Okay, so your dot product would end up being just A squared. These are less common. Okay? This talks about if you've got two vectors adding together and you're trying to dot product them, you can dot product these two and then plus the dot product of these two. Okay? This is showing you that it doesn't matter which order you multiply them in. Okay? So if it's A dot B, it's the same as B dot A. And if you've got a factor at the front, then you're only going to multiply that by one of these before you dot product. Okay? So it's not like FOIL, you don't multiply by both of them. Okay, it's only multiplied by one of them. I think I'll leave these examples to later. Alright, okay, so I'm just recording this so we've got it on the notes. So remember that the order is important, so that's why we had to change this one to 2. And then once you've done that, to find either 3, you just subtract those 2 from 1. Okay?